Hello everybody, Dr. Powers here. Today we're going to go over Project 2 for MAT240 at Southern New Hampshire University. We're going to look at what is asked of you in this assignment, what you need to do. We'll go through Excel and the functions you need to use and so forth. So let's get started. So it's week 7. This project is going to be asking you to run some hypothesis tests to see if there's evidence that population parameters are this or that. And so the scenario, as with all the other weeks, we're looking at real estate data. So what you're going to do first off is you're going to be selecting one of the regions of the country, and you'll be asking these questions of that region. Are the housing prices in this region on average, I'm inserting that because it's important, are housing prices or listing prices on average lower than the national average? Is the square footage of homes on average different than the national average? And then we also want to calculate a 95% confidence interval for square footage of homes, the average square footage of homes in this region. So first off, these are the three things that are asked of you, and actually parts 2 and 3 are kind of wrapped into one section of the assignment, because a two-sided confidence interval in many ways is equivalent in a sense, at least mathematically, to a two-sided hypothesis test. So, I mean, that's that. So what we're going to be doing is, that basic overview is enough for us to get started. I'm actually going to walk through the Excel work, and so I'm actually going to go down and download our house listing price by region. We need this. We're going to download that, and we're also going to need the National Summary of Statistics and Graphs Housing Listing Price by Region. Okay, so the National Summary, this is important because we're going to be looking at two variables in this real estate data, the listing price and square feet. We're not going to be looking at cost per square feet in this assignment, and also we are not pairing the variables and looking at the relationship between them. So there is no need for any scatter plots in this assignment because we're not looking at the relationship between listing price and square feet. We're looking at each of these variables independent of the other. All right, so just to make that totally clear, no scatter plots. All right, no regression equation, no line of best fit, no residuals. We're not doing predictions. All right, so but this is what we need. We're going to need two numbers from this: the mean listing price for the nation and the mean square feet for the nation. All right. You'll also be looking at these histograms to see if your sample distribution is similar to the national. And you'll also be comparing your sample data to the sample statistics, the national, but that really is going to be happening through the use of the tests. So let's go to Excel, and in Excel we're going to want to enable editing, of course. All right, so what we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 regions of the country. Pick your favorite region or your least favorite. Doesn't matter to me if you like it or not. You can pick one at random. Let's go to Mid-Atlantic for no reason whatsoever. All right, so what we have on each of these worksheets is a listing of about 1,000, like a little more. I don't know if it's 1,001 or 1,000 actually. So I'm actually going to count. So these are the listing prices. Let's go to the top. Indeed, 1,001 listing prices. So that's correct. We're going to, as we've done before, create a random sample. So remember what we've done. We are asked in this assignment to pick a random sampling of 500 listings from this region. So you can see here in the assignment, pick the region. we're going to take a sample of 500 observations, and that's what we're going to be using for this whole test, or this whole assignment. So we put in the formula, the random number, and remember use the formula equals RAND, parentheses, parentheses, and that I'm going to copy that down to the entire column. I'm going to go down to the bottom row actually and paste it from the bottom to the top. That's going to help me get it everywhere. So we've got random numbers, and of course they're going to be regenerated every time I change something on the sheet. But I'm going to just sort by the random column, and that effectively shuffles up the data. So under the data menu, I'm going to sort and sort by the random column. Okay, we've done this a bunch of times, and I'm going to I'm going to select both 1 and 2, and then if I auto-complete this, it's going to go 3, 4, 5, 6, 7. All right, quickly go down to, that'll help me count 500 rows. Okay, there's my data. You know what I'm going to do is I'm just going to delete everything below that. I'm going to take all of these rows from 506 down to the bottom, delete that. I don't want that data. What else am I going to do? I'm going to delete the cost per square foot. Don't need that variable. It's just cluttering things up. The only two variables I care about are house listing price and square footage. All right. Things you need to do in this assignment: create scatter plots of them. Easy to do. Remember, if you select the house listing price, I'm going to select the whole column and go from the top to the bottom and click on Insert. And I'm going to go under the charts. There's this one has some statistical charts, a histogram. Well, this is a very skewed distribution, is it not? This is listing prices. I'll call this Mid-Atlantic sample listing prices. Okay, so we have 500 listing prices, and you can see there must be at least one that's up really, really high, 5 million something dollars, which is why this distribution skews so far. But most of them are down here. It looks like 514,000. Oh no, what is that? 814,000. That's like 900,000 is like the top of most of them, and then there may be one or two outliers. Okay. Now, why do we need a histogram? Because the central limit theorem says, well, if you're sampling from a normally distributed population, and then the sample mean, if you standardize the sample mean by subtract the sample mean from the population mean and divide by standard error, you should get a statistic that follows a t-distribution, and that's what we use to do these tests. If your population is not normally distributed, then you need to address that. Well, the population from this distribution here, it certainly looks like it's not normally distributed. This sample distribution is certainly not a normal curve. It's very skewed to the right. However, it's a really large sample size, 500. And so even with a skewed distribution like this, a large sample size such as 500 is going to allow for the sampling distribution to be a t-distribution, even though the population is not a symmetric distribution. So that's something you need to address in your work. Mention that the assumptions are satisfied for a t-test. And so what do we do for this t-test? All right, we're going to need a couple statistics to do this. To answer the question, is the average listing price in the region significantly lower than the national average? All right, so we need to know that, and let's cut away these two columns because they're just distracting. What's the national average? The national average listing price is $288,407. I'm going to go copy that number back over to Excel. So what I'm doing, I'm going to write it here, but my null hypothesis is that on a Windows, I've learned this recently, Alt 230 makes the mu equals 288,407. That's the null mean. if the null hypothesis is true, the regional mean is equal to the national mean. If the null hypothesis is, the alternative hypothesis is that alt 230 mu is less than 288,407. So this is a left-tailed test. So to perform this test, what we need to do is calculate some statistics. We need the sample mean, sample standard and deviation, sample size, and then we're going to calculate the t-stat and the p-value. Okay, so we're going to go through these statistics and just the formulas for them. Now you could use the data analysis tool pack. It is problematic for some people. Some people have Mac and they don't have the same version of it. And I am running a new version of Excel, and for whatever reason, the data analysis tool pack for me is just not working. So I'm going to do the formulas by like manually, and it's not really that bad. So we'll walk through what you need to do. So equals average. We need the average for our listing prices. I'm going to do the average, and I'm just going to click on column D, D to D. It's going to ignore the words and just going to average the numbers. So that's my sample average. All right. Sample mean or sample standard deviation is equals stdev dot s, and then parenthesis, column D, all of column D. All right. And the sample size, I know it's 500, but just to be sure that I didn't mess up, I'm going to use equals count and count the number of values in column D. Indeed, 500. So I have the right amount. That's good. That's a good way of just checking to make sure I didn't delete too many rows or something like that. Now, the t-statistic is calculated by you take the difference between the sample mean, it's sample mean minus the null mean, the null hypothesis mean. So I'm going to say equals to create this formula, equals, and I'm going to take the difference between sample mean minus the national mean, 288,407. Okay, take that difference. Now I'm going to divide that by, and another parenthesis because I want to make sure that the calculation doesn't get messed up, the standard error, which is not the standard deviation, but it's the standard deviation divided by square root, SQRT, the square root of the sample size. Okay. Now that's going to finish off this statistic. I'm getting negative 4.17. This is it's a fairly extreme, although some of the regions you get a far more extreme t-statistic, probably. But anyway, you're going to get something different because you have a different random sample. But here, so in the distribution, -4, that's far off to the left. It seems to me there's a lot of evidence supporting the alternative hypothesis. This is much lower than 288,000. And to find out how, the t-test really is looking at the probabilistic question. If the null hypothesis were true, and in the mid-Atlantic region, the population mean listing price really is 288,000, how likely is it that a sample of 500 could give us a sample mean of 249,000 with such a high standard deviation? Well, this will put a probability number to that, and we'll say, well, is this a very likely kind of thing to see under the null hypothesis, or is this a very unlikely thing to see? And indeed, we'll see it's very unlikely. To find, since this is a left-tailed test, we're going to use equals t.dist, the t-distribution probability calculation. And I put in this t-statistic, comma, degrees of freedom is going to be 500 minus 1. That's my degrees of freedom. For the t-test, it's sample size minus 1. Okay, comma. And then you have to say true. True to get the cumulative probability. False gives you the density. We never use that. And unless you're really doing some mathy stuff, you wouldn't need the density for this. So that's all you need. This will give us a p-value, and it's going to be basically 0. Okay, so Now, this isn't scientific notation. In Excel, if you want to have this in kind of regular notation, go up and press the comma style, and then let's extend the number of zero places. So that's a more easy to understand kind of in decimal notation rather than scientific. 0.0000178. That's how likely it is that we could have seen sample data like this coming from a distribution like the null hypothesis says. Very unlikely. What does that mean? That tells us that we really have very strong evidence to in favor of the alternative. It's the null hypothesis is very implausible. We reject the null hypothesis because there is strong evidence, extremely strong evidence, that the mean listing price really is less than the national average. And that's what you want to write. And that's how you're going to go about doing your first t-test. For the next one, then you're going to be asked, is the average square footage in the region significantly different than the national average? And what's the national average square footage? It was 1,944. I'm going to copy that value, bring it back to Excel, just put it here, and we're going to go through the same thing. Now, for the null hypothesis, it's that the mean, and here the parameter I'm looking at is the mean square footage for this region, right? And so when you're asked what is the parameter, it's asking what is the symbol mu symbolize in this test? It's here, it's the mean square footage for the region, population mean, right? Not the sample mean. I know what the sample mean is. That's just easily calculated. But the population mean requires some inference. I need to kind of, say, well, based on the data, what can I infer about the population mean, right? That's the population parameter. Anyway, 1944 is the null mean value. And the alternative, now I don't have, I want to put in a character. I'm going to go to the insert menu for a symbol, and I'm going to go to, in the math, let's see, I want to get the not equals sign. I have it in my recently used symbols. I'm going to just insert it from there. Mu is not equal to 1944. I'm doing a two-tailed test because the question is asking if there's evidence that the square footage is different than the national average. Okay, now I'm going to need the same stats. I'm going to need the sample mean, sample standard deviation, and sample size, but I need them from the square footage column. Easy to do. Average of column E. Okay, stdev.s for column E. And this is something that I do not get, that it puts a dollar sign on the average, but standard deviation it doesn't put a dollar sign on. They're the same units. It's also in dollars. So I'm actually going to put this in dollars. Sample size, of course, is 500, but I'm going to just to be safe, I'm going to use count just to show you again how I did it. Count everything in that column E. Now the t-statistic, it's the exact same formula. In fact, I can actually take this up here and copy this and paste it right here, and that's going to give me the formula for the t-statistic. What is it again? It's going to be the, okay, so I'm taking the sample mean minus the null mean, so 1,692 minus 1944, in parentheses, that's the numerator, divided by the sample standard deviation, right, over the square root of sample size. And that gives me a t-statistic. When you have dollars divided by dollars, you lose the units, and so the t-statistic is unitless. There's no units for this statistic. It's just a measurement. Now, negative 17 is insanely far from 0. In the terms of this distribution, the p-value is going to be 0. Now, what would happen if I was to use, if I use the t.dist? Now, I'm doing a two-tailed test, so I would use the 2t, okay? If I put this value in with 500 minus 1 degrees of freedom, I would expect this far out in the tails, you should have basically 0. But I'm getting a big problem. Why? You should always use absolute values for your t-statistic for this formula. So I'm going to go back in to here, and I'm not going to use J29, which is my t-statistic, but the absolute value, ABS parenthesis J29 close parenthesis. That's the absolute value of negative 17. And that goes in, and then we're going to be good. Now so you said E negative 53. I'm not going to extend the decimal places because there are 50, that would be 52, it's 0.0000, 52 zeros before the 9531. Okay, so for all practical purposes, this is 0. It would be virtually impossible for the regional square footage average square footage to really be 1,944, and yet a sample of 500 gives me data like this. That's basically impossible, and that's what you want to say when you're concluding. It's not just strong evidence. This is emphatically, undeniably strong evidence that the null hypothesis could really not possibly be correct. The chances that the null hypothesis population could result in data like this is 1 in a, I don't even know the name for that, 1 out of a billion, something like that. Many more billions than that. A billion only adds, 9 zeros, so that's 52 zeros. You have to do that almost 6 times. All right, so there we go. Now, this is just giving us the conclusion from our hypothesis test, but you're also asked to calculate a confidence interval. Now, we can do this a couple of ways. What I'm going to do is calculate the margin of error, and what we're going to do is add and subtract that margin of error to our sample mean to see what is our 95% estimate for what the population mean is. And there's a formula in Excel, confidence.t. It gives you the what this gives you is the margin of error. So I'm going to give it alpha, which for a 95% confidence interval, we're using 0.05 for our alpha. The standard deviation is actually calculated right here, and the sample size is calculated right here. So those are my inputs for this. This 28 number is square feet. So what I want to do is take my sample mean and subtract this $28, or not dollars, square feet. Now, why is it putting dollars around this anyway? Square feet. Why is it putting it in dollars in the first place? I don't know why. Why did nobody tell me I was doing this? It's not in dollars. This is just a regular old number. Okay, it's not dollars, people. They're square feet. Okay, so I got 1,663, and then I've got this sample mean plus the margin of error. And then we've got our bounds for our confidence interval. Our lower bound, our upper bound. So when I write this up in my paper, I'm going to talk about how I'm 95% sure that the population mean for the Mid-Atlantic square footage is somewhere in the range of 1,663 and 1,720, 0.82. And that's, so I'm pretty sure, very confident that those bounds are estimating the true regional mean. And this is very much in line with my conclusions from the hypothesis test, which said that there's very little evidence, or there's really no plausibility to the idea that 1,944 could be the mean for the region. That's far outside this interval, and so it's really far outside the realm of plausibility. So that is all of the Excel stuff that you'll need to do. Oh, I didn't produce the histogram for square footage, but you're asked to do that as well. Notice I'm looking at house listing price and square footage independent. Like I said, no scatter plot, no line of best fit, no regression equation. We're not doing any of that. when you are running your paper, be sure to go through all of this stuff that you're asked for. In the introduction, you are asked to talk about how the confidence interval will be used to help look at this question about the square footage. If you don't include that in your introduction, you will lose points. Be sure to include a couple sentences talking about how you'll be producing a confidence interval and what that's going to tell you about the square footage estimate. Okay, that's important. For when you talk about the introduction, you want to talk about both of the tests that you'll be doing in this paper, not just the first test. And then when you do your one-tailed test, remember you're going to be checking the conditions. You're going to look at the distribution, talk about outliers, and you need to justify that the conditions of the t-test are satisfied. And as a little spoiler alert, it's likely your distributions are not going to be normally distributed looking, but your sample sizes are so huge that it's not going to be a problem. Notice you're actually asked to talk about the median as well, but you know how to calculate the median. Use the median function in Excel, so you can get that pretty easily. Okay, and then the two-tailed test you're asked to do. Remember, at the end of the two-tailed test, you are asked to compare the results to a 95% confidence interval and interpret it. When we say interpret, it means give a clear sentence explaining what it means to somebody, so somebody who hasn't taken stats would understand what the lower bound, upper bound represent. Like, what do they actually tell us? And then at the conclusion, you're asked to summarize the findings, basically go through what you've discovered in this paper. So for the two questions, what your conclusions were, but also talk about if you were surprised at all by these findings, if you had some preconceived ideas. Don't omit this discussion section, because you're graded on that, and it's going to be all in the template. You have all these sections, but also be sure, like always, go through the rubric, look through all these sections. You can see how many points each of them are worth, because that's what you'll be graded on. And if you don't satisfy the, if you do everything that's in the proficient column, but then try to do it even better, you're going to get exemplary and you'll get full credit and you'll get 100 on this. So I hope you do. And as always, if I'm not your instructor, ask your instructor questions, and I'm sure you'll do well if you follow these guidelines. And I really hope you do. And I hope you finish the term successfully. All right. Well, take care. Bye.